Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video on integrals of the product of trig functions is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended that you view the video integrals of trig functions with exponents prior to watching this video. In this video, we will be discussing integrals of the form sine to the mx times cosine to the nx dx, tangent to the mx times secant to the nx dx, cotangent to the mx times cosecant to the nx dx, and integrals of the form sine a times x times sine b times x dx, sine a times x times cosine b times x dx, and cosine a times x times cosine b times x dx. Integrals may be taken of the form sine to the mx times cosine to the nx, where n and m are integers. In this first example, we use a function where m is odd, in this case the integral of sine cubed x times cosine squared x dx. In these cases, we use the identity sine squared x plus cosine squared x equals 1, or for this case, sine squared x equals 1 minus cosine squared x. Next, we split the sine cubed into sine squared x times sine x and place the sine x on the right. Then we substitute sine squared x for 1 minus cosine squared x. Next, we let u equal cosine x, which will make du negative sine x dx. When we substitute these values, we get the integral of the quantity of 1 minus u squared times negative du. Distributing the u squared and the negative gives us the integral from u to the fourth minus u squared du. When we take this integral, we get u to the fifth over 5 minus u cubed over 3 plus c. Substituting u for cosine, we get our final answer, cosine to the fifth x over 5 minus cosine cubed x over 3 plus c. Integrals may also be taken of the form sine to the mx times cosine to the nx, where n is odd. In this case, the integral of sine squared x times cosine cubed x dx. We'll still use the identity sine squared x plus cosine squared x equals 1. But for this case, we use the form cosine squared x equals 1 minus sine squared x. Next, we split the cosine cubed x into cosine squared x times cosine x, and move the cosine squared to the left. We then substitute cosine squared x for 1 minus sine squared x. Next, we let u equal sine x, which will make du cosine x dx. When we substitute these values, we get the integral of the quantity of 1 minus u squared times u squared du. Distributing the u squared gives us the integral of u squared minus u to the fourth du. When we take this integral, we get u cubed over 3 minus u to the fifth over 5 plus c. Substituting u for sine x, we get our final answer, sine cubed x over 3 minus sine to the fifth x over 5 plus c. In this next case, we solve for sine to the mx times cosine to the nx, where n and m are even. For example, we can solve the integral of sine squared x times cosine to the fourth x dx. Here, we also use the identity sine squared x plus cosine squared x equals 1, or sine squared x equals 1 minus cosine squared x. We substitute sine squared x for 1 minus cosine squared x, then distribute the cosine to the fourth x and separate the integral at the minus sign to get the integral of cosine to the fourth x dx minus the integral of cosine to the sixth x dx. We can now solve each of these integrals individually, as we did in the previous lesson, then combine the two answers. We'll start by taking the integral of cosine to the fourth x dx. Here we need the identity cosine squared x equals 1 plus cosine 2x over 2. Now when we substitute, we get the integral of 1 plus cosine 2x over 2 quantity squared dx. Again, we can separate 1/4 as a constant and FOIL the numerator to get 1/4 times the integral of 1 plus 2 cosine 2x plus cosine squared 2x dx. Next, we separate the integrals at the plus signs. We can now use the same identity to change the integral of cosine squared 2x dx into the integral of 1 plus cosine 4x over 2 dx. Now we take each integral individually and save the constant c for the end. The integral of dx is x. Using u substitution, 2 times the integral of cosine 2x dx is 2 times the quantity of sine 2x over 2. Next, let us separate the integral of 1 plus cosine 4x over 2 dx into 1/2 times the quantity of the integral of dx plus the integral of cosine 4x dx. This integral is 1/2 times the quantity of x plus sine 4x over 4. Next, we simplify the inner parentheses to get 1/4 times the quantity of x plus sine 2x plus x over 2 plus sine 4x over 8. We then combine the like terms to get 1/4 times the quantity of 3x over 2 plus sine 2x plus sine 4x over 8. We then distribute our 1/4 to get a final answer, 3x over 8 plus sine 2x over 4 plus sine 4x over 32 plus c. Here we'll save our answer to the integral of cosine to the 4th x dx, and now work on the integral of cosine to the 6th x dx. The integral of cosine to the 6th x dx is solved using the same identity as we did for cosine to the 4th. In this case, the identity substitution leaves us with the integral of 1 plus cosine 2x over 2 quantity cubed dx. We start by taking the cube of the denominator and moving it outside of the integral as a constant. Then we take 1 plus cosine 2x and cube it to get 1 plus 3 cosine 2x plus 3 cosine squared 2x plus cosine cubed 2x. We can then separate the integral at the plus sign and get 1/8 times the quantity of the integral of dx plus 3 times the integral of cosine 2x dx plus 3 times the integral of cosine squared 2x dx plus the integral of cosine cubed 2x dx. Again, we'll take each integral individually and save the constant c for the end. The integral of dx is x. 3 times the integral of cosine 2x is 3 sine 2x over 2. For 3 times the integral of cosine squared 2x dx, we apply the identity to get 3 times the integral of 1 plus cosine 4x over 2 dx. For the cosine cubed term, we first split it into cosine squared 2x times cosine 2x. For the next step, we'll bring down the first two terms as the integrals have been solved. Next, the third term, we can move the 1/2 outside the integral and split the terms to get 3 over 2 times the integral of dx plus 3 over 2 times the integral of cosine 4x dx. In the fourth term, we replace cosine squared 2x with 1 minus sine squared 2x, based on the identity sine squared x plus cosine squared x equals 1. For the next step, we again bring down the first two terms. 3 over 2 times the integral of dx gives us 3x over 2. 3 over 2 times the integral of cosine 4x dx gives us 3 times sine 4x over 8. To solve the last terms, we let u equal sine 2x, so that du equals 2 cosine 2x dx. When we substitute, we get the integral of the quantity of 1 minus u squared times 1/2 du. We take the integral to get 1/2 times the quantity of u minus u cubed over 3 plus c. When we substitute back, we get sine 2x over 2 minus sine cubed x over 6 plus c. Next, all we have to do is simplify. First, let's distribute the 1/8 to get x over 8 plus 2 sine 2x over 16 plus 3x over 16 plus 3 sine 4x over 64 plus sine 2x over 16 minus sine cubed x over 48 plus c. We can combine x over 8 and 3x over 16 as like terms to get 5x over 16. 3 sine 2x over 16 plus sine 2x over 16 equals sine 2x over 4, plus 3 sine 4x over 64 minus sine cubed x over 48 plus c. We can now replace this answer in our original equation, remembering to retain the minus sign, and simplify. 3x over 8 minus 5x over 16 gives us x over 16. Sine 2x over 4 minus sine 2x over 4 cancels out. Sine 4x over 32 minus 3 sine 4x over 64 gives us negative sine 4x over 64 minus sine cubed x over 48 plus c is our final answer. Integrals of the form tangent to the mx times secant to the nx may also be solved using a similar strategy. In this case, m is odd, as in the example, the integral of tangent cubed x times secant squared x dx. This time, use the identity tangent squared x plus 1 equals secant squared x. We rewrite our identity to tangent squared x equals secant squared x minus 1. Then we split tangent cubed x into tangent squared x times tangent x, so we can substitute tangent squared x for secant squared x minus 1. I'm also going to split the secant squared into secant x times secant x and arrange it so that secant x tangent x dx is at the end of the integral. Next, we let u equal secant x, which makes du equal to secant x tangent x dx. When we substitute, we get the integral of the quantity of u squared minus 1 times u du. We distribute the u to get the integral of u cubed minus u du. When we take the integral, we get u to the fourth over 4 minus u squared over 2 plus c. When we substitute back in for u, we get our final answer, secant to the fourth x over 4 minus secant squared x over 2 plus c. Integrals of the form tangent to the mx times secant to the nx, where m is even and n is odd, can be solved by using the same identity. For example, the integral of tangent squared x times secant x dx. This time we substitute tangent squared x based on the identity, then distribute the secant x to get the integral of secant cubed x minus secant x dx. We can then separate the integrals at the minus sign. The integral of secant x dx is the natural log of the absolute value of tangent x plus secant x plus c. We'll save that answer and subtract it from our solution to the integral of secant cubed x dx. The integral of secant cubed x dx can be found using integration by parts. We remember that integration by parts gives us the integral of u dv equals u times v minus the integral of v du. We first split secant cubed x into secant squared x times secant x. We let u equal secant x, making du equal to secant x tangent x dx. Then dv would be secant squared x dx, making v equal to tangent x. So the integral of secant cubed x dx is equal to secant x tangent x minus the integral of tangent squared x secant x dx. Referring back to our identity, we can substitute the tangent squared x with secant squared x minus 1. In this next step, secant x times tangent x does not change, and the new integral is secant cubed x minus secant x dx. When we split the integral at the minus sign, we have the integral of secant cubed x dx equals secant x tangent x minus the integral of secant cubed x dx plus the integral of secant x dx. We can now add the integral of secant cubed x dx to both sides of the full equation, giving us 2 times the integral of secant cubed x dx equals secant x tangent x plus the integral of secant x dx. We next divide both sides by 2 and get the integral of secant cubed x equals 1/2 times the quantity of secant x tangent x plus the integral of secant x dx. We take the integral to get the answer to the integral of secant cubed x dx as 1/2 the quantity of secant x tangent x plus the natural log of tangent x plus secant x plus c. We now combine our two answers to get the integral of tangent squared x secant x dx equals 1/2 the quantity of secant x tangent x plus the natural log of tangent x plus secant x minus the natural log of the absolute value of tangent x plus secant x. If we distribute the 1/2, we get secant x tangent x over 2 plus the natural log of tangent x plus secant x all over 2 minus the natural log of the absolute value of tangent x plus secant x plus c. If we use a common denominator on the last term, we can simplify to our final answer, secant x tangent x over 2 minus the natural log of the absolute value of tangent x plus secant x over 2 plus c. From the last few problems, we can deduce a general strategy for solving integrals of the form tangent to the mx times secant to the nx dx. Notice the identity is the same, just taking different forms. Since the identity cotangent squared x is equal to cosecant squared x minus 1, we can deduce that similar integrals can also be taken if they are in the form cotangent to the mx times cosecant to the nx dx. The next form of integration is for those of the form sine ax times sine bx dx, where a and b are integers. As an example, let's take the integral of sine 3x times sine 2x dx. This can be solved using the identity 2 sine a sine b equals cosine quantity a minus b minus cosine quantity a plus b. If we divide this identity by 2, we have a useful substitution. We now have the integral of 1/2 quantity cosine 3x minus 2x minus cosine 3x plus 2x dx. The 1/2 can be moved outside the integral as a constant, then add like terms. Then we split the integral at the minus sign. Now when we take the integrals, we get 1/2 times the quantity of sine x minus sine 5x over 5 plus c. When we distribute our 1/2, we get a final answer, sine x over 2 minus sine 5x over 10 plus c. In a similar manner, we can find the integral of sine ax times cosine bx dx using the identity 2 sine a cosine b equals sine quantity a plus b plus sine quantity a minus b. We'll use the integral of sine 3x times cosine 2x dx as an example. Again, we divide the identity by 2 so as to match the integrand and substitute. As before, the 1/2 can be moved outside the integral as a constant, and combine the like terms, giving us 1/2 the integral of sine 5x plus sine x dx. We split the integral at the plus sign and take the integrals to get 1/2 the quantity of negative cosine 5x over 5 minus cosine x plus c. We distribute the 1/2 to get our final answer, negative cosine 5x over 10 minus cosine x over 2 plus c. The final form is integrals of the type cosine ax times cosine bx dx. This one requires the identity 2 times cosine a times cosine b equals cosine quantity a minus b plus cosine quantity a plus b. And we'll use this to solve the integral of cosine 3x times cosine 2x dx. Again, we divide the identity by 2 so we can substitute, combine the like terms, move the 1/2 outside the integral, and separate the integral at the plus sign to get 1/2 times the quantity of the integral of cosine x dx plus the integral of cosine 5x dx. When we take the integrals, we get 1/2 times the quantity of sine x plus sine 5x over 5 plus c. We distribute the 1/2 to get our final answer, sine x over 2 plus sine 5x over 10 plus c. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you and good luck with your studies.